Hello everyone. Today we are going to see a question in which we have to find the orders pair of integers, that is x and y, which satisfy the equation. So simply writing the equation in rearranged form, that is by cross multiplication, we have xy equals to 12, that is again multiplied by 12. Okay, so we can just simply write xy equals to 12 to the square, that is 144. Okay, so this part we have 12. So this can also be written in form of 4 into 3, that is 12. Okay, so because we have an identity that states that AB square A into B square equals to A square dot B square, that is A square into B square, A square multiplication with B square. Okay, so this part can again be written as, because we have considered it as 4 multiplied by 3, so this whole part can be again written as xy equals to 4 comma 3 4 into 3 square, that is 4 square multiplied by 3 square. Again the same identity we have applied, not the same but a different one, that states that a raised to the power b raised to the power c equals to a raised to the power b into c. So just multiplying b and c. Okay, so for this we have 2 raised to the power 2, again raised to the power 2. Okay, so this is 4 raised to the power 2. So we can write it in the form of 2 raised to the power 4. Okay, so we write this part as 2 raised to the power 2 raised to the power 2 dot 3 raised to the power 2. Okay, so we're going to write this part. Okay, we have xy equals to 2 raised to the power 4 into 3 raised to the power 2. So just leave it here. Before we proceed further, let's see more the understanding that we required for this solution. So we have a concept of prime factors, uh, not prime factors, a series we have. Okay, so we can call it a series that states that a raised to the power alpha, b raised to the power beta, c raised to the power gamma, and so on for the d delta and e neta, so on the term goes on. Okay, so here a b c, this is a note point that you should remember, that for a series that states that a raised to the power alpha, b raised to the power beta, c raised to the power alpha, d raised to the power delta, and so on, where a, b and c and so on are prime numbers, then the factor of this series, then the, you can write, if a, b, c are prime factors, then the factor of the series are, this factor are total number of factor. Okay, this factor are, then the total number of factors of the series are alpha plus 1 multiplied by beta plus 1, gamma plus 1, and so on. Okay, so it will be better if you just take a note of this important point, and if it's clear we can head forward. You can pause the video and take the screenshot of this particular part, or just note it down. Okay, let me just rub it quickly. Okay, I hope this is clear. So the same, whatever the understanding we got till now, let's apply it on an example. Okay, then we will come back to the question. So an example we have is, for example, we considered 18. So for the 18 we can write it as 2 into 9, that is again 18. or we can write 9 into 2, that is again 18. Okay, so this 2 into 9 can be written as 2 into 3 raised to the power 2. Now see, 2 is a prime number and 3 is a prime number, and it has a power of 1. So the factor for this, according to the note that we have earlier seen, we have alpha plus 1 beta plus 1 equals to total number of factors. Okay, so the same concept we are applying here. Here we have alpha equals to 1, alpha equals to 1 and beta equals to 2. Just simply writing it in the equation, 1 plus 1 and 2 plus 1. We have 2 into 3 equals to 6. So the total number of factors we have 6. That we can also see in the pairs form, we can also see. Okay, so this is 6 we are getting. So let's just show how we are getting 6. Okay, so we got for the 18 we have 6 factors. Okay, so the 6 factors are 1, 2, 3, 6, 9 and 18. So how we have 1 into 18, that gives us 18, 2 into 9 gives us 18, 3 into 6 gives us 18. See, whatever the number of factors you have, the half will be repeated one. Okay, we have 1 into 18, so we can just reverse it. 18 into 1, just reverse it. 9 into 2, just reverse this. 6 into 3. These are the pairs of factors that we have. Okay, ordered number of pairs for the 18. See, this is not the complete solution for this. If in the question you are given the total number of pairs that you have to calculate for 18, so it will be not 6, it will be 12. So how this is? Okay, you must be confused about this. So just see this. You have 1 into 18 giving you 18, but also we have minus 1 into 18 minus 18, that gives us 18, because minus minus equals to plus. Okay, so if in the question there are two options for the calculation of if the question is like you have to calculate order number of pairs of integers for x and y. Okay, so you have to consider the negative answer also. So for this the number of factors will be 12 factors if it's stated in the question. If it's not there, then go with the 6 option only. Okay, that is 6 factors. Let's come back to the question now. I hope the explanation will be enough. For solving this, we have to just keep in mind that for the prime numbers we have a series, that is a raised to the power alpha, b raised to the power beta, c raised to the power gamma and d raised to the power delta, and so on. So for these total number of factors equals to alpha plus 1, beta plus 1, gamma plus 1 and so on. Okay, so just apply the same thing on this equation. Our 2 is a prime number and 3 is a prime number, and these are the value of alpha and beta. So here we have alpha equals to 4 and beta equals to 2. So simply the total number of factors, first of all we will calculate total number of factors, that is alpha plus 1 into beta plus 1, that is 4 plus 1, 2 plus 1. Solve this, we have 5 into 3, that is 15 number of factors. Okay, So here we have 15 answer. So you must be thinking that this is the correct answer. Okay. So what we have talked about is the negative we have to consider. Okay. Pair. We are talking about pair. Okay. So this is the total number of factors. Okay. So for this we have 15 factors. Okay. But because you have to consider the negative terms also, negative terms that will be same as the positive terms, we will be having 15 negative terms and 15 positive terms, which gives us 15 pairs. These are the 15 pairs, these are the 15 pairs that we get. So the total answer is 30 ordered pairs of integers x and y that satisfy this equation. Okay, so our answer will be A.